a binary tree. Let's look at this tree to begin with. To know if a tree is balanced, we need to look at branches, and then we need to look at the heights of branches. So the left branch for this tree, starting all the way up at the root, would be a height of 3. And then the right branch of this tree would be a height of 2. So we have 1, 2, 3, and then 1, 2. Now, that gives us a difference of 1. So 3 minus 2 is 1. And if we ever have a difference of just 1, then we have a balanced tree. If we have a difference of 0, it's a balanced tree. And if we have a difference of greater than 1 between any kind of branch in any subtree within a tree, then we have an unbalanced tree. Let's look at what an unbalanced tree would look like. Well, we have this tree, and then we're going to insert a new node. So a new node is coming in, and then this new node is going to be 14. As it's coming in, it gets compared to the root, which is 22. Then we know that we have to go to the left side. So we compare it to 17. 14 is less than 17, so it goes to the left. Then we compare it to 15. 14 is less than 15, and it goes to the left again. Now we have a branch that is of height 4. 1, 2, 3, 4. But we also have a branch that is just of height 2. So 4 minus 2 ends up being 2. Now that is greater than the 1 that we were looking for to have a balanced tree. So this means that this particular tree is unbalanced and we have to find a way to balance it. Now when does balancing happen? Well, balancing happens right at this point, right before anything gets inserted. So we have inserted it or inserted a new node, we know where it goes, and we figured out whether this node has unbalanced anything. How does it figure to do that? Well, it happens recursively. So this subtree will figure out if it's balanced or not, then this subtree will figure out if it's balanced or not, this subtree will figure out if it's balanced or not, and finally the root subtree will know whether it's balanced or not. So each node has its own responsibility to figure out if it's balanced or unbalanced, and then each node has to figure out how to fix it before anything else gets inserted in the future. So let's look at different possibilities of unbalancing. We have a left-left unbalance, and when we have a left-left unbalance from the root, then we have to pick a pivot point, which would be the left hand side reference for the root, in this case 15, and then we shift the root down to the right side of the pivot point. Now we have a balanced tree. In this case, we have another unbalanced tree, which happens to be right. We pick a pivot point, which happens to be to the right side of the root, and then we shift the root to the left side of the pivot point. What if we have a right-left unbalance? So this is the root of the tree. To the left, that branch is of size 1 because there's nothing there. To the right, it's of size 2 or 3. So 1, 2, and 3. So 3 minus 1 ends up being 2. So we have an unbalanced tree. And what do? Well, we shift these two so that we end up with a right imbalance. And then we use a pivot point like before. So in this case, we're going to use 17 as the pivot, which is to the right of the root. And then we're going to shift down the root. And now we have solved our right-left imbalance by shifting it first to a right and then creating the solution for right. What happens when it's left-right? Well, same thing. We want to create a left-left imbalance. So we shift these two. Now 13 is less than 17, so that would be okay. This happens to be still an imbalanced tree, so what do? We pick a pivot point, which would be to the left of the root, and then we shift down the root. In this case now, we have a balanced tree. Now let's look at this particular tree. How is it going to know where it needs to shift from? So we're going to start by saying that this is a left-left imbalance, and we're going to figure out how that left-left imbalance happens. So we have this newly inserted node. This newly inserted node is going to figure out what its height is and whether there's a difference in heights between its left and right nodes. So it goes, what's my left node's height? What's my right node's height? Now I'm going to figure out whether there's an imbalance. Well, in this case, there's just 1 for both. 1 minus 1 is 0. So that particular node is balanced. Now this node, number 15, looks at both of its nodes. On the left, right, says what's their height. Well, on the left, I have height 2. On the right, I have branch of height 1. So I'm balanced too. 2 minus 1 is 1. here we have on the left height of 3, on the right a height of 2. 3 minus 2 is 1, so that's balanced. And then we look at node 22, which happens to be the root node for this whole tree. And it says that on the left it has this height 4, but on the right it has height 2. So 4 minus 2 is 2. And whenever we get a difference in balances of 1 or greater than 1, then we have an imbalanced tree at that node. So this node needs to fix itself. Now, how is it going to fix itself? Well, if we remember that left has a pivot point, so the node to the left of the root would be the pivot point, and then we shift the root down to the right side of the pivot point. So here we have a left imbalance, and we choose a pivot point to the left side of the root, which in this case would be 17, and we shift that down to the right. Now, this has happened, and we have to figure out whether we have any other imbalances. Well, sure, we have. So we fixed the left imbalance, but we might have created another imbalance, so we have to check that. So let's go through the new nodes and see if we have any possible imbalances. Well, this node is not imbalanced, it's just 1, 1. This node is not imbalanced, it's 1 or 2, 1. This node happens to be imbalanced. It's 3, 1. And we have a right imbalance at node 18. So how do we fix right imbalances? Well, we pick a pivot point to the right side of the subtree's root, and we bring down the root to the left side of the pivot point, and now we've got a balanced tree. So let's do the same. We pick the pivot point right at 22, which is to the right side of the root of the subtree, and then we shift them over, and we have now balanced the whole tree. So this whole tree is now balanced. There are no nodes that have an imbalance at any point. And if we notice, we have the left branch of 17 is now 3. The right branch is 3. 3 minus 3 is 0. So this is a perfectly balanced tree. How do we do that, say, in code? Well, in code, we're going to figure out where imbalance is. So in this case, we're going to go with balance of 3 minus 1. So it would be 3 minus 1, and I'm doing this so that there's different ways of you looking at it. If you were counting this as 0, 1, 2, 3, then y would have a height of 3, and on the right side we have 0, 1 would have a height of 1. So you can do it in different ways. It really doesn't matter whether you pick 0 or 1 as the beginning of the height. So I'd like to show both. Now we're going to do balances of starting from 0. So we're going to say x is this new variable, which happens to be to the left of y. And y is an imbalanced node that we figured out that is imbalanced. So what are we going to do? We're going to save the left side of y, because that's going to be our pivot point. And then we are going to figure out that there is a t2 variable, and that happens to be to the right of y. So if we take those two variables to the right of x, sorry, so we'll have x right equals y. So whatever's at the right side of x, put the root node on the right side of x, just like how we saw that we fixed left imbalances. So then we'd have this happen. And then we have this dangling T2 over here. So instead of doing another right imbalance like we did where we shifted everything, our algorithm will do that automatically by putting T2 right on the left side of Y. So the same thing that we saw before gets done with this rotating right algorithm. Now there's different ways to rotate. You have a rotate right, rotate left algorithm in your problem set. So you can use those that have been created for you already to rotate your tree at the correct times. These algorithms are widely known, so I've already implemented them for you, which you can find anywhere. I'd rather you use them in the correct spots so that you'll be able to fix the different problems with balancing your tree.